Hello, everyone. I'm Anil Madan. Just some background. I run the marketing, analytics, and product engineering at PayPal, where my team builds basically solutions and infrastructures for experimentation, clickstream tracking, personalization, cookie, amongst others. Prior to that, from a background, I've been with eBay for several years, where I had both the distinction and privilege to work on eBay's entire Hadoop infrastructure, ranging from petabytes at scale. What I'll be hoping to do today in the next 30, 40 minutes would be walk you through a couple of key scenarios of where we leverage Couchbase, specifically around our cookie store and our personalization. Quick background of PayPal for those who are not familiar with it. We are clearly a leader in online payments. With 155 million users across 203 markets, we operate globally across 100 distinct currencies. Our online space, our online products provide you both simple and safe ways to pay, where $1 spent in every $6 on e-commerce is going through our global systems. Just from a scale perspective, in Q2 2014, our payment systems did processing of transaction payment volume of 55 billion in the entire quarter. That's about 9.3 million payments every day. So, as you can see, uptime, reliability, availability are very, very key to everything we do at PayPal. Why Couchbase? We get this question very often, across a whole multitude of distinct vendors. Our use cases basically had to operate at very high volume. Our online systems have, at any given time, we need to handle about 1 billion plus distinct documents. Each range from about 4 to 10K in size. So at any given time, we have to deal with 3 to 10 terabytes of storage in our online systems. From a data access, when we looked at the entire slew of vendors, we needed something which basically would give us both caching as well as persistence. So really, the durability has to come with the cache. So a lot of our use cases were things around write-through caches, which needed the backend storage. And instead of investing in two distinct tiers, we chose Couchbase. From a data structure, the recommendation I'll have, there's just so many vendors in the industry. Be very careful of what your data structure is, because that's the key which in turn determines what the tool or the vendor of your choice would be. For us, it was primarily document-based in the couple of scenarios, at least I'll walk you through. With that said, we do leverage a lot of distinct vendors for our other systems. So the key there being, it's important to choose your vendor or your solution based on the data structure. The workload characteristics for the use cases, which you'll see, basically had a 50-50 read-write. So anything we had to come with its lower latency, anywhere ranging from 5 to 10 milliseconds in our scenarios. And finally, as I walked you through the payment scale, everything we have to do has to have availability, scalability, multi-data center, business continuity, and disaster recovery inbuilt into the infrastructure. So let's go right into our first use case, which is our cookie store. So, the business problem and the background we had on this problem was there was 15 years of abuse of our client cookie space. So over time, across 14, 15 years, our cookie space was fairly ungoverned. It kept on growing organically to a point where we started seeing both client-side errors because the modern browsers would just not handle those kind of payloads, and in some cases, server-side errors because certain servlets or web servers would just not be able to deal with such high cookie payloads. There was, of course, associated customer experience impact because there were form abandonments. Somebody's going through a checkout flow, which is key to the payments business, and they would just get dropped off intermittently. There was performance impact because of just the higher bandwidth which was flowing back and forth on the cookie space. And then of the security, because certain cookies in our ecosystem were just not secure. So when we were tasked with actually solving this, there were several goals we had in mind. we had to reduce the cookie payload by at least 70%. Certain cookies which are more client-side, like JavaScript, we just cannot migrate them seamlessly on server. But for the rest of them, we had to basically be able to, or in a position to migrate them all onto server-side. They had to be a central repository for cookies, which meant that we wanted to build in the governance associated with the infrastructure. The approval process for our 3,500 developers would need a cookie has to be brought down to less than a day. It used to take weeks prior. And then finally, whatever we do had to have the 4 nines availability built into that. So when we started getting into this problem, it was really a maze and a puzzle. You had 4 distinct stacks of being in their generations of either migration or growth. So we had C++ stacks, we had Node, we had Java, we had others being leveraged by our third parties. So the problem at hand was these stacks would both read and write cookies. So you had to start figuring out, auditing which cookies would basically was shared, which were isolated. So that was one dimension to the problem. The second dimension to the problem was just over again the 15 years of abuse, certain cookie values were encrypted. In some cases, even the names were encrypted. And these names were just all over into our millions of lines of code. And again, the cookies themselves could be session or persistent. So you had now a whole complex ecosystem of all these cookies. So when we started embarking on leveraging Couchbase, there was a lot of analytics we also had to build into the process so that we go after this problem in a much more disciplined way. And I'll be sharing that as we go through the journey. So the migration strategy, when we started looking into how would we actually really change this ecosystem of migrating all our client-side cookies into server-side, meant that you had to start with auditing analytics. So you had to start understanding which use cases or applications were reading or writing cookies, which ones were shared, which ones were isolated, come out with really a good regression plan, and then go through the actual dual mode for some time. What that means is that the same cookies would now, while primary would still be the browser, we would start migrating them silently on the server side when it came to Couchbase. So we would run these cookies in dual mode for some time till we are completely confident that we have transitioned them all onto the server side, do the actual migration followed by rigorous monitoring, and then rinse and repeat that whole process. So that was really the business problem at hand when we took this journey. Going into the architecture and the functional view of how we kind of came about. So our customers are interacting with our platform globally across a bunch of distinct channels. These range from mobile to web, to desktop, to point of sale registers. Each of these interactions would have to go through our frontier, which is really where all the application stacks were. So whatever you saw in the previous slide of 4 distinct application stacks would basically are reduced down to that figure called application there. That's where we would plumb in our cookie libraries. The cookie library, think of it really as a client to the cookie service, which will actually deal with the marshalling, demarshalling, and the serialization. The cookie service is something which we basically constructed, which embedded the Couchbase client. And then the cookie service, in turn, would talk to a multi-data center deployment of Couchbase with 2 distinct data centers with disaster recovery built in. The deployment model, which is really what the most interesting part, I guess, for some of you would be, we had 2 active data centers where the third one was passive in case of disaster recovery or business continuity. We would trigger that. The application, when the call really comes to the application would get a unique locator, which is basically has a affiliation to the data center. So the locator would in turn determine which Couchbase instance it talks at the back end. And the writes will happen against that data center. In case the writes fail, we built in fault tolerance and redundancy into the system where the application will be able to retry from the cookie service into the second cluster, which is also active. So that's where you see that cross data center call. Of course, we will incur the latency in that scenario. The reads again would basically work against its own data center, because now we have dropped a unique locator, which represents really an indirection into the Couchbase cluster. And then, of course, in case the writes had failed and you had gone to the second data center, the read would, of course, be going directly to that data center. There is bidirectional XTCR happening between the two active deployments. So this is what Ravi covered in the morning of Couchbase 3.0 and how they are making a lot of the improvements. So we are really exercising the XTCR, and we're really exercising it to its limit right there. Now, when it comes to actually one of the, either because of code maintenance, rollout, or in the eventuality where we lose one data center, we have a passive deployment of this, which is the third cluster there, where we have unidirectional XTCR happening against from each of the co-locations. So now you basically have built for not only redundancy, but you've also built for reliability in this infrastructure. So let's take a quick look at basically what our deployment, what our configuration is. So we use dual octa-core as far as the hardware is concerned, the compute is concerned. Each have local 3 into 1.2 terabytes of SSDs with 256 gigs on each of the nodes. There are 10 distinct nodes in each of the clusters, so you have basically 30 distinct servers there serving this entire cookie traffic. Also, as I kind of alluded towards our migration strategy, a lot of this had to go through rigorous analytics when it came to really understanding how the migration would happen. So what we did there was we basically built out a Couchbase Kafka adapter, and we've also open sourced that in the GitHub on PayPal with the link below, where the data would actually get streamed into Hadoop, and using Kafka Consumer, which is the Camus implementation, we would collect all this data into Hadoop. That's where we'll run those distinct MR jobs to basically find out the cookie usage and its adoption and its migration. Looking at basically the schema at a very high level is very, very simple. Imitating the HTTP cookie payload, really, with distinct name value pairs for session and persistent cookies. With the distinct fields there, just the key things from what an HTTP header would provide you as out of the box from the cookie. On the cookie documents and the analytics is concerned, this is where it became very interesting when you start talking about billions of hits and cookies being read and written on a daily basis across these millions of users. So the thing is, it had to be seamless behind the scenes. So we built a bunch of distinct document types. So in this slide, what you see, there's a cookie audit, which basically would have the metadata of every cookie and its last update. So it will basically capture the name of the cookie, its encrypted name, because a lot of our cookies were encrypted. So the name here was just clear text name, and then the last modified. This would now start giving us really what cookies are being used, and including the rogue cookies. And it'll also start telling us, basically giving us an entire inventory of all our cookies. The cookie metrics actually had the time series, especially at an early granularity of each cookie, as far as which apps are reading the cookie, which apps are writing the cookie, how many reads are happening across an app per cookie, and how many writes are happening across a cookie, along with how many have been killed. So this was very useful as we started going through the transition itself. The other interesting documents which we had to create as part of this was really a user session map. So one interesting problem we ran into as we started migrating this blindly was that we saw a lot of bots which were coming in on a daily basis, trying to do account takeovers, trying to have fraudulent activity. In order to curb all of that, we basically limited the sessions. So a particular user could just have 10 distinct sessions. This way, what the unabated growth which was going on all cookie infrastructure started to be curbed, because now you had a handle to bots, and you could basically limit it to just 10 distinct user sessions. And finally, for every user, we had to basically maintain a migration status against every cookie. So this basically started giving us enough insights and analytics to where each user was from a migration strategy. Our cluster, I think I talked a little bit about that. We have 10 nodes in each data center across about a couple of terabytes of storage, and then 256 gig against each compute node. And the data buckets themselves, I think the cookie was the key bucket with distinct document types of the ones I just outlined, where 4 of them were primarily for analytics and 1 being the key which maintained all the entire user's payload. The second scenario was the second big use case where we leverage Couchbase in a big way is personalization. So our users, are again interacting with us across a multitude of channels. These are online channels which are on site, where users are actually coming in and making a payment. These could be our pre-logged in pages where there's a lot of marketing and where we are driving users into PayPal to either acquire them or to activate them. And then some of our newer retail channels, whether these are beacons or pay codes or our mobile apps. So each of the users are interacting again across these channels. The goal for us is to how do we start personalizing experiences for our consumers, whether these are on the merchant side upstream. So we have a very thriving ecosystem of merchants who leverage PayPal with the Pay with PayPal button. So we want to even start going into personalizing experiences right there on the merchant sites. These experiences could be on PayPal owned and operated properties, or these could be our publishers through our advertising networks, where we leverage mobile and hyper-local capabilities to really target and provide them with compelling experiences. The bottom is really our data and science, where we can do a lot of segmentation, modeling, our location-based services, and our customer journeys, which is where we basically stitch in journeys of how the users have evolved over time. And the data, again, is not only just our first-party data, but also third-party data sets. So as users are transacting, interacting with us across all these channels, the business problem for us is we would like to reach out to these users across all these distinct channels, provide extremely relevant interactions, and these are highly custom, tailored experiences which are relevant, and really and support redemption across these, because our ecosystem and our value proposition is to grow and help grow the payments for both merchants and for PayPal. So our goal is to basically provide them with these consumers these compelling experiences, so that we can really grow our transaction payments volume. So the goal for us is to increase redemption. So this is where the personalization system starts coming in play, which is again based out of Couchbase, where we maintain a Uber identity, which in this example is that profile ID in the middle. And then you have a bunch of distinct identities, whether these are third-party identities, these are social identities, these could be identities from eBay or PayPal, which is our first party in this case. Across, again, things like email, home address, demographics, your mobile identity with IDFA. So all of those identities need to come together to build that Uber profile, and that profile basically needs to provide that personalized experiences. So at the heart of it is really a couple of distinct document types, which we call both identity and profile, where the identity record in this example, taking this in detail, would have really a master profile ID, which is called as master ID in there, and a bunch of either stronger or weaker identities. So email could be one. You could have a bunch of emails, which are being matched to distinct heuristics. Could be an eBay identifier, which based on your browse behavior on eBay, and this could be a PayPal identity where you've actually transacted on PayPal. The profile basically would be constructed now across a bunch of these distinct identities. These could be things around your demographic, things around your status with PayPal, things around your credit standing, or with what your status of your account is along with the PayPal balance. So all of that, the key elements of the profile come together into what we call as the profile document. Taking this example even further, so you have all the profile, the master identities with distinct profiles. So what you see is that those keys in this are your distinct identities, which basically take you to the master profile. And the profile itself would have all these match keys, which are basically used to construct that profile with distinct segment providers. So the segment provider could be PayPal, could be eBay, could be third party, where it'll have attributes around when each profile was created, when it was last updated. Now, those two pieces from a timestamp are required because then we can really have the semantic reconciliation being done by the client, because the client can then choose, if there are conflicts on the profile, to which one wins, because we, trying to just have all that on the personalization would be hard, just on the server side. And then distinct segments from, let's say, eBay in this example, and it could be demographics either through third party or internally. The cluster, again, at a high level on this is we have basically 26 nodes in this cluster, which again is a multi-terabyte deployment, this is a single cluster in this example, as opposed to the previous example where you had distinct multiple clusters. The other unique thing about this deployment is this is on a cloud virtualized environment, while the cookie infrastructure is on bare metal. So we also have tried and tested Couchbase in distinct deployment scenarios. So that's what is unique to this cluster as far as its deployment is concerned. From a sizing perspective, basically we deal with, in this example, there are about 1 billion identities which we are dealing on a daily basis, with profiles about 350 odd there. And the transient profile which you see is in a lot of our scenarios, we may have segments which are basically in experimentation phase, which means that they aren't really true segments till we actually graduate them, where there are several use cases would need them, or these become standardized. So for really that test and learn, we separate them out into transient profile, where we can do a lot more experimentation, see which ones will really be the true standardized segments, which we can graduate back into the profile itself. So with that, I would love to take any questions if they are. So the question, just to repeat, is you would be interested in how we are trying to work towards bringing the latency down in a multi-geographic deployment. So XDCR is actually a good question, because we've been spending a lot of time in the last 2 or 3 months on that. Typical latency which we are seeing, some of it, of course, is just the network latency attached with just multiple data centers and its deployment. What we've seen on the ground is we've seen about 300 milliseconds across across our deployment. Now, specifically on what we've been doing on that, which is really the crux of your question, is around what we've been doing is, really trying and testing Couchbase 3.0 with that in-memory XDCR, because today the way XDCR is it first checkpoints and then it actually transfers data. So what we've been kind of testing rigorously has been the Couchbase 3.0, where we really look, where they have the capability of in-memory streaming, and that's the part which we've been testing right now on that.
Were there any architectural or data modeling decisions you had to make to take bidirectional XDCR into account?
See, the key thing for us there when we really went with that bidirectional XDR was the availability, because for us basically with the cookie infrastructure has to be highly available and it cannot go down, and all the key cookies, some critical cookies will start depending on that. So from a XDCR itself basically provides that resolution and how it does the versioning. So we do have certain versioning inbuilt which are more like logical versions in our documents, which are also being used besides the XDCR when we do the conflict resolution, because the higher version should trump. And then you have to design around the eventual consistency, because the data center B in this example, which I outlined, would be eventually consistent. And now if the failure happens, the failure should be able to fault tolerant in a seamless way to B. But then the assumption there that the XDCR latency should be lower than true browser activity from a user. So typical user activity would be, even if a dwell time on any page would range from 1 to 2 seconds. We are currently seeing 300 milliseconds from a eventual consistency, and we are working towards reducing that. So the short answer is yes, through logical versions. File storage, flash. So the SSD basically is kind of really low latency. It's giving us data locality. We haven't really tried flash. Yeah. We are using SSD. Yeah. Sorry, can you maybe be a little louder? I apologize.
So just based on the numbers here, it looks like half of the RAM is actually being used. Is there a reason you put 26 nodes there just for extra capacity, or what's the bottleneck?
Yeah, so you're right. I mean, the usage is low right now, but the way we have built this is to basically serve entire PayPal traffic, so it's over capacity right now just because going into the quiet period, we would be ramping a lot more on our personalization scenarios. Today, a lot of them are marketing, but we're getting into more of product scenarios where every product interaction would get personalized.
Does PayPal use or plan to use Couchbase for its financial transactions?
So financial transactions is still primarily deeply Oracle for now, and I think right now we are still learning our way into this technology. I think it's been now about a couple of years with really a year of true live traffic, especially on the cookie infrastructure. So as of now, probably not. But with that said, as NoSQL is disrupting the cost, the total cost of ownership would come down, and along with it will come the stability and the reliability on these kind of deployments. So at some point we may make the decision, but as of today, no, we are primarily Oracle when it comes to transactional systems.
Have you compared the total cost of ownership if you implement the same system using Oracle?
So The question is, the total cost of ownership with Oracle. See, the thing is, the key thing, as I was kind of alluding towards in the first slide, it's the data structure, right? So the data structure, is really document oriented, right? So trying to shoehorn that into relational is just doesn't make sense. I mean, the same question could be like, look, why are you not using information retrieval system like Elasticsearch? So the key thing, as I kind of pointed right off the bat, it's very, very important as the world is moving towards what we call as quote unquote polyglot storage, that you choose your database first based on the data structure, and that's a function of your application. Don't use a graph for a document or a key value for a column, right? It's important to choose your data structure based on the app first. Sorry, can you?
You mentioned about the cookie infrastructure. How much of it is stored on the end side, user side?
How much of it stored on the user side?
Is there any part stored on the user side?
So what I outlined was really the migration process we are going through. So think of it, when we started that entire initiative, all cookies were actually on the client side. And that's where the abuse was and where we were getting payloads being dropped. What we are doing is migrating that over, for most part, onto the server side. And there'll be few JavaScript cookies which we may not be able to, and certain locators which would more be indirection into Couchbase. Those are the only pieces we eventually would leave on the client side. But everything else would basically be migrated on the server. And now with the server side, this gives us a much higher payload, because now the applications can come in and really manage state in a self-service way, which because now there's an infrastructure on the server side to kind of imitate cookies. Any more questions? Thank you, guys.